Okay, so for question 5, what we're going to do is first I'm going to name my equations. So I'm going to call the first equation equation 1, and then I'll call the second equation equation 2. Now what I want to do is I want to take one of my equations and again either isolate for y or x and then plug it into my second equation to solve it. But in this case, I noticed that both my equations have fractions in it. So technically there's nothing wrong with fractions. It's just that when you have fractions, a lot of students have trouble, I guess, dealing with them. So what I would recommend is to try to get rid of the fractions first by multiplying the denominator by an equal term in the numerator. So for example, let's say we start with equation 1. Inside of equation 1, we have x over 4 plus y over 2 equals to negative 3. I'm going to start by simplifying that one down. So by simplifying it down, what I mean is x over 4 can actually be written as 1 over 4x, and then y over 2 can be written as 1 over 2y. And I'm going to let that equal to negative 3. Now, what I have here is, okay, so my highest term in the denominator is 4. So what I want to do is I want to multiply every term by 4 because that gets rid of my denominator. So let's say I go times 4, times 4, and times 4 to every term. If I do that, let's see what I get. Well, 1 over 4 times 4, that means I have 4 on the top now and 4 on the bottom. So the 4's cancel out. So all I'm left with is just x. And now let's look at y. For y, I have 4 on the top now because I'm multiplying 1 over 2 by 4. So I have 4 over 2. So that should give me 2. So now I have 2y. And now I have negative 3 times 4. Well, negative 3 times 4 should just give me negative 12. Okay, so now I have x plus 2y equals to negative 12. And that's my new equation for equation 1. Let's look at equation 2 now and see if we can form a new equation from it. So for equation 2, we have x plus y over 5 equals to 6. And again, I'm just going to rewrite this as x plus 1 over 5y equals to 6. And from here, I want to multiply my denominator I want to multiply every term in my equation 2 by the denominator, pretty much by the denominator value, which is 5. So I want to multiply every term by 5. So by doing this, I get rid of my denominator. And if I multiply every term by 5, here's what I get now. X times 5, well, that should just be 5x. 1 over 5 times 5, that should give me 1 because the 5 and the 5 cancel out. So I should just get y. And then 6 times 5, that would give me 30. So now I have 5x plus y equals to 30. So now that I have these new equations, let's use them to solve via substitution. So we can either manipulate 1 or 2. If I choose to manipulate equation 1, I feel like I can just isolate for x. But if I manipulate for equation 2, I can isolate for y. We always seem to manipulate for 1, so let's switch it up and manipulate for 2 this time. So for equation 2, let's manipulate for that one instead. So we got 5x plus y equals to 30. Okay, so let me draw a line here so we know like this is separate or a little bit more separate. So here we have 5x plus y equals to 30. Let's isolate for y. So to do that, we can subtract 5x from both sides. And when we subtract 5x from both sides, what we're left with is y equals to minus 5x plus 30. Okay, so now we have isolated for y in equation 2. So now we want to plug equation 2 into equation 1. Okay, so for equation 1, I have x plus 2y equals to negative 12. So if I plug in equation 2 into 1, what I have would be x plus 2 times negative 5x plus 30. And that equals to negative 12. Okay, so let's simplify. X plus, okay, now 2 times negative 5x, that should be negative 10x actually. So, I'm just going to change the signs right here. That's negative 10x. And 2 times 30 should be plus 60, so positive 60. And that equals to negative 12. Now let's try to add the like terms together. Well, we can't. Well, I guess we could. What I'm going to do is I'm going to add x and negative 10x together. So x minus 10x, that should give me negative 9x. So now I have negative 9x plus 60 equals to negative 12. So from here, what I'm going to do is I'm going to keep x on the left-hand side and move everything else to the right-hand side. So I'm going to subtract 60 from both sides. And if I do that, I should be left with negative 9x. And 60 minus 60 is 0. So I have negative 9x equals to negative 12 minus 60. And that should give me negative 72, if I'm not mistaken. Okay, so now I have negative 72. So from here, what I'm going to do is I'm going to divide 9, the negative 9 by both sides. So let's divide negative 9 by both sides so we can have only x by itself. And if we do that, we should have x equals to negative 72 divided by negative 9. But the thing is, can we reduce negative 72 equals to negative 9? And the answer is yes. So first, let's cancel out the negatives. So we have two negatives, a negative 72 and a negative 9. So let's say that's 72 over 9. And now, what's 72 divided by 9? That actually gets us 8. So we can actually say that x equals to 8. So that's one term that we found right there. We found our x term. So x equals to 8. So now let's take x and plug it back into one of our equations to solve for y. Since we already have y isolated for in equation 2, let's plug x back into equation 2. So in this case, we'll do it here. Y equals to negative 5x plus 30. So y equals to negative 5. Now we'll plug in our value for x, which happens to be 8. And we'll continue on and say plus 30. Now, negative 5 times 8 should give us negative 40. And now we have plus 30. So y equals to negative 40 plus 30. Well, negative 40 plus 30 should just be negative 10. So we can say that y equals to negative 10. So now we found our second point. So now that we found our 2 points, we can say that our point of intersection is going to be at x equals to 8 and y equals to negative 10. And that would also be the solution to our system of equations.